Hi everyone, I'm Biagi, and today I just wanted to show you this cool problem a friend of mine proposed. It says to find all pairs of primes p and positive integers n such that p cubed plus p squared plus p plus 1 is equal to n squared. So, the first thing we are gonna do is factor this left hand side into p plus 1 and p squared plus 1. Now notice that the greatest common divisor of p plus 1 and p squared plus 1 is equal to the greatest common divisor as p plus 1 and p squared plus 1 minus p plus 1 times p. And this is just due to Euler's to Euclid algorithm. Hence, this is equal to the greatest common divisor as p plus 1 and minus p plus 1. Um, actually we can just do p minus 1. This is way quicker. And here we simply get 2. And since we can clearly see that p equals to 2 gives us 15, that is not a perfect square, p must be greater than 2, hence it must be odd. And this is simply 2. Hence, this term of the product is of the form 2x squared, and this term of the product is of the form 2y squared. And these have x and y have to be co-prime due to the last algorithm, and they both have to be squared since the product of two co-prime integers is a square if and only if they are both squares. So the problem now reduces to finding the solutions to this um, system of equations. And to do so, we're gonna um, move the plus 1 to the other side. Let's call this one equation 1 and this called equation 2. Then subtracting equation 1 from equation 2, we get that p times p minus 1 is equal to 2 y squared minus x squared, that we can factor as y minus x and y plus x. Let's now notice that 2 only divides p minus 1, so we get p times p minus 1 over 2 is equal to y minus x times y plus x. And at this point, p is hmm, so p either divides okay, let's now use that y and x are co-prime. Therefore, these two terms are co-prime, and therefore either p divides y minus x or p divides y plus x. Um, but due to bounding reason, we have that p must divide this one, and therefore, again, by bounding reasons, p must also be equal to it. So p is equal to y minus x, and p minus 1 over 2 is equal to y minus x. I would say subtracting equation 1 from equation 2 and then dividing by 2, we get that x is equal to p minus 1 over 2 sounds about right, and that is equal to p plus 1 over 4. Hence 2x squared minus 1 is equal to p becomes p plus 1 squared over 8 minus 1 is equal to p. And now this is a simple second degree equation, and we get that it has a root as p equals to 7, and this is the only one, as the graph goes about like this, and they only have one prime intersection. I mean, this is gonna just grow a lot bigger. We now check that p equals to 7 is indeed a solution, and we get 343 plus 49 plus 7 plus 1, and that is equal to 350 plus 50, that is 400, and that is indeed 20 squared. So the only solution is 720. Hope you like this problem. Bye, have a great night, stay hydrated, stay silly.